Hello, for this video we're going to look into LeetCode problem 427, construct a quad tree. The task here is to build a quad tree representing of a binary tree where each node represents a subsection of the grid. If all the values in a section are identical, then it creates a leaf node. Otherwise, it recursively divides the section into four smaller quadrants. So let's go through the question. Given an n times n grid of zeros and ones only, we want to represent the grid with a quad tree. Return the root tree quadrant as a grid. Okay, so a quad tree is a tree data structure in which each internal node has exactly four children. Besides, each node has two attributes. So the value, which is true if the node represents a grid of ones, or false if the node represents a grid of zeros. Notice that you can assign the value to true or to false when it's a leaf, and both are accepted. So we are gonna assume that the leaf, so here, is always a leaf. What does this mean? That all the values are the same, right? So false means that it's not a leaf, so it's a node, so that means that all the values are not the same, and then we need to divide it by 4. If the leaf is true, then the node is a leaf, and then the tree is false, and then the node has to be fortune. Yeah, so there you go. So then you have your node is gonna be a value, a leaf, the type of value, which is a boolean, the boolean to see if it's a leaf or not, top, left, right, and bottom. We can construct a quad tree with two-dimensional area grid. So here you more or less can see what the grid looks like, how you will subdivide it, the top left, top right, bottom left, bottom right. How can you start thinking about this? So let's look at example 1, right, and try to understand this. So we have an input grid that is 0, 1, and 1, 0. So how do we read this list if they don't give us this little diagram? So we're gonna get our main list, right? So we get the way this will be grid equal the main list. And then on this line, we do the smaller list, which is 0, 1. We close it, comma, and the next line, we put 1, 0, comma. So it's a list of lists. So then we can look at this here like that, right? That's what's cool about that. So this example is not a leaf because the values are not the same. On the list 1 and on the list 2, the values are not the same. So this is a node. And then our output will be 0, 1, 1, 0, 1, 1, 1, 1, and 0. So all of the possible. The example of this example is shown below. The notice the 0 represents as false and 1 represents as true, the photo represented. So if we look at this here, right, what we have here is this whole thing is not a leaf, so that's 0, because if it's a leaf it's 1, right? So it's not a leaf and it has a value of 1. Why it has a value of 1? Because it has one quad tree under it. And then this quad tree has 1 leaf, 2, 3, and 4 leaves. See, 1 represents the leaf, and then you have all of your values, right? So 0, this leaf, all the values are 0. This leaf, all the values are 1. The next one, all the values are 1, and then the right one, all the values are 0. So let's look at example 2 real quick, and then we can code. So then we have these, right? So our lists are like this. So then how can we divide this? Because now we know we need to divide it, right? So we have our list of lists with all of these inside. So if this is n, right, and this is n, because they give you n times n, that's our list. So this is n times n, this square is n times n. We can divide n by 2. This is like simple. And then that means that this is n by 2, and this is n by 2. And the same here. So then we divide the matrix into 4 quadrants. So why do we want to do this? Because then we want to know, okay, so then this is a leaf. This next quadrant is not a leaf. This is a node. And then this is a leaf. And then this is a leaf, right? It's our 4 quadrants. So if we look at the division here, they kind of did it for us in the diagram. We divided one quadrant, 2 quadrants, 4 quadrants, and then this one has to be divided by 4 because it has different elements. So if you want to see it as a diagram, here more or less represents the tree, right? So you have a tree with 4 quadrants. You have a node with 4 quadrants, and then you have, for that node, 3 of them are going to be a leaf. One of them is going to be another node, and that node is going to have its own 4 quadrants, and that's when it stops. So how can we do this in code, right? So let's keep it around here, and let's go through the code. So first, we know that we have our node, and then we're going to start our definition. So we're going to do a DFS, which is to read through all the information in a matrix. So then our rows and our columns. So you can use this to read through Excel sheets and all of these, So you have your number, your n number. So this number right here of this distance. So right here it will be 8, right? Because this list right here, this is my list bigger and this is my smaller within the list of lists, right? So I know that this is 8 elements. So that's my number. My row is going to be this one, and this is going to be my column. So if I want to put this in an index, this is 0, 0, right? If I look at this in coordinates, this is 0, 0. So then I know that my 0, 0 on this list is going to be this number. So then we can do that. So then we know our definition is going to need the length of our grid to know the n, and we're going to need the 0, 0. So here we can return, so for our main function, we're going to need to call our function, right, within the function. But we need to activate it. So to activate it, we're going to need the length of the grid, and then the 0, 0 of that matrix. Okay, and then once we have these, we're going to assume it's valid, right? Because we want to assume that it's always a leaf. So it is a leaf. If it's a leaf, right? If is valid, then I want to return the node with the grid at 0, 0. So the first value, because that's the value that we're checking, right? So the 0 are the row and the column, comma, true. Why? Because it is a leaf, and leaf is true. So here. Okay. So then, to make sure that it's valid and it's true, we need to iterate through the list, right? So we're gonna do an iteration through each column, each row. So our iteration is gonna go through each row, and each time it goes through a row, it's gonna check each one of the columns. And then once it checks all of the columns, it goes to the next row, checks all of the columns, next row, and etc. So then for us to do that, we need a for loop. So for I in range of n, so that's our range, and then for j in range of n. And then if our grid, right? So now we need to check if every single element on this list is the same at this element, my 0, 0 as 1, right? For this example, it will be 1. So I need to check if every other element on this list after this 0, 0 is not equal to that element, right? Not equal to the 0, 0 plus I and plus j, because the I at each iteration is 0, 1, 2, 3, 4, and then the j becomes your index. So 0, 1, 2, 3. So we're checking recursively through each one of the rows and each element. So let's say when it hits this one, it's not equal. So if it's not equal, then it's not valid. So our valid becomes false. And then we break, because we don't want to go through the full list if we found it before, right? So what does that mean? So then we need to make our division. Then we do our quad tree. So we can go by n is going to be equal to n divided by 2. So this is going to give me an integer, like a full value of absolute division. And then we need to check all of these, the top, the left, and the right, because what we're going to do here is we're going to populate the top, the left, the both tops and the bottom, each one of these quadrants, with the list, with all the values inside the list for each one of these quadrants. So if we have this matrix, we need to access 0, 0, 0, 4 to start from 0, right, for this value. We will need 0, 4, no, 4, 0, so we jump all of the rows, and then 4, 4, right, because then we're in the center and it will give us this value right here. Okay, so then to do that, we need to basically call our function rows and columns, so we can populate and break these each one of these lists to that, right, based on the grid. There you go. So now this is my 0, 0, because we assigned it here, and then we need to move to the next column, the top right. We need 0, 4. So we know that our n now is 4 for this example. So then we need to move to the next column. So the next 4 columns is n. So then this 0 plus 4 is 4. So then it will move from our matrix, it will move here. So then if we want to move to the bottom left, then we add n here. And if we want to move to the center, which is the rest, we do n there and n there. And then here, we want to return our node, because now we populated this. So then we want to do the 0, because it is a leaf, and then false, and then comma, and then we want to return all of these values. We want the populated values, right? So we go here, and that's left, right, there. And that should work. So if we run it now, means I have typo. Okay, so return outside the function. So my this whole if statement needs to go after the 4, I believe. So let's do that. And try uh, mm, turns outside the function. Yeah, there you go. So this return is the one from this definition, and this is similar. So that worked for both cases, and let's submit it. And it didn't do bad. It's like on the better side, 76. So I hope that worked. This really helped me understand what trees and how to break them down. So I hope it does it for you too. Thanks for watching.